probability distribution, finding the mean, variance, and standard deviation, but this time using Excel. There's going to be an easier version and a fancier version. We're still working with discrete data, so these are the things we're still going to need to find. So here's some Wordle data, and I like this one because it's discrete, so it works for this lesson. So you have your, how many guesses it took, and then how many times that happened. So I have all of the number of guesses in column A, and then the frequency in column B. These are not decimal kinds of things, these are count kind of things. So therefore, we are working with discrete. Okay, so the first thing I want to do is I want to take my frequencies and I want to change them into probabilities. But before I do that, I'm going to need to find the sum of all my frequencies. So I want Excel to do math, which means I need to start by typing in equals. So equals sum, open parentheses, choose all of that, highlight all of the frequencies, hit enter. I get the number 345. So in my probability, the easy version is that I am going to use the number 345 as opposed to the location where that is. So equals, I want my individual frequencies divided by, and I'm going to type in 345. And I'm going to grab this here and drag it down to the end of my data, not the 345 because that wasn't one of my original points. That was just the sum. And then that gives me enough information to find that very coveted x times p. So I want it to calculate, so I start with equals. I click on my x times, and then I click on my p. Enter. I'm going to drag that to here. My mean is the sum of that. So I have equals the sum of, and I highlight all of my x times p values right here. So I get that mean. I'm going to go over to I want to put my squared deviations times p over here. So I want it to calculate, so I start with equals, open, whatever my x value is minus my mean. My mean I'm going to type in is 4.09275, close, square, times p. My p value is right there. Enter. And I'm going to make it do that several times. That's the beauty of the spreadsheet. Do it several times for me. And now my variance is the sum of those square deviations times p. So this would be equals sum of the stuff I just found. There's your variance. And the standard deviation is the square root of your variance. I click on that. There we go. That's the easy version. So in the fancy version, I'm not going to type any numbers in when I need a mean or that kind of thing. So for probability, then I didn't find the sum of my frequency. So I'm going to say equals whatever this is, and then divided by the sum of, now I do want the sum of all this, but I'm going to use dollar signs to lock in the locations so that way it doesn't move on me. So the first one would be right. If I drag it down and I didn't put the dollar signs in, then anything afterwards would be moving things down. Choose these empty spaces down here. We don't want to do that. So I want to do math. So I start with an equal sign. This times this, x times p. All the way down here. And then the mean is just still going to be the sum of all of that, because that's one of the things that's expected of me in my homework. So there's the mean right there. Notice that the point of what we were doing was that we didn't find the particular number for the total count of the frequency, and that 345, we didn't bother finding that, so this is something that is recyclable, so to speak, because I didn't hard code a number in. Now, in order not to type in the mean here for my squared deviations times p, then I'm going to say equals, first of all, because I wanted to do a calculation. So it's x minus, now the mean would be in this spot, but I want to lock in that it's in this spot, it's not going to move, so I'm going to put a $sign on that. When I don't want the number to change, I put a $sign on the number. When I don't want the column to change it, then I put a $sign on the letter. So squared times probability, and I can drag all that down. So I didn't type any of the numbers in that are specific to this problem, therefore I can reuse this. And then my variance is equal to the sum of those square deviations times p. And my standard deviation is equal to the square root of my variance.